Good day to all the dear students. This is chapter number 11, Coordinate Geometry, part 3 of standard 10th. In this, I have continuing with exercise 11a, but some more questions which are very important to understand. So please take your textbook with you and read the question number 9, exercise 11a. If x1, y1 is 2, 3, x2 is equal to 3 and y3 is equal to minus 2 and g is 0, 0. So find y2 and y3 values. y2 and x3 values. Okay, so here in this question we are given coordinates x1, y1, x2 and y3. And this is g. G means the centroid of a triangle. So just now we have used centroid of a triangle formula. For x is x1 plus y1 plus x1 plus x2 plus x3 by 3, and y is y1 plus y2 plus y3 by 3. So this is very simple. We substitute the value x, that is centroid coordinates 0, 0. So x also 0, x1 is already 2, x2 is given 3, x3 we have to find out. So I substitute same x3 as it is. Here y coordinate is also 0, so substitute 0, y1 is 3, y2 we have to find out, and y3 minus 2. So substituting all the values here, we can find the missing values. So now 3 multiplies 0, it becomes 0, 3 plus 2, 5 plus x3, therefore x3 will be minus 5. Similarly 3 into 0, 0, and y2 3 minus 2 plus 1, therefore y2 is equal to minus 1. So these are the values they asked to get, x3 and y2. So likewise you can use the formula to get the values. Question number 11. Question number 11 is the vertices of a triangle are A minus 2, 2, B 4, 4 and C 8, 2. Now find the lengths of the median. So here you can see triangle ABC is drawn, whose vertices are written here, and these are the medians AN, BL and CM to the sides AB, BC and AC respectively. So now we have to find the length of these medians, all three medians. So for that, first of all we have to find the coordinates of this midpoint of this point M, N and L. Why? Because median, so it will be the midpoint of the side only. So first of all I am writing M, X, Y, the coordinates of point M. The formula for the midpoint is x1 plus x2 by 2 and y1 plus y2 by 2. So substituting value x1 minus 2, x2 4. y1 is 2 plus y1 is here 2 plus 4 divided by 2. So 4 minus 2, 2 by 2, 4 plus 2, 6 by 2. So here I get coordinates 1, 3. Whose coordinate are they? M. Point M's coordinate will be 1, 3. So similarly, I'll find coordinates of N. So point N coordinates here I write N. I do not write the formula, but N means this side BC. And side BC's coordinates are already written. So directly applying x1 plus x2. That is 4 plus 8 by 2. And 4 plus 2 by 2. So here 8 plus 4 12 by 2 and 4 plus 2 6 by 2. It means 6 and 3. So N coordinates will be 6, 3. Okay, now going to next third point, that is point L. We'll find its coordinates first by midpoint formula. So point L here is equal to minus 2 plus 8 by 2, 2 plus 2 by 2. So 8 minus 2, 6 by 2, 4 by 2, that will be 3, 2. So these are the coordinates of L. So now students, we will write using distance formula the lengths of all the three medians. So first of all, I write the median to the side AB. So the first answer to the AB, it is CM. So length of CM, for that we have to use coordinates of C and M. And the formula for distance, that is x2 minus x1 whole square plus y2 minus y1 whole square. That is also given in our first video, how the distance formula is derived. Now I take C and M points for this, already told. So x2, x1, whichever you want to choose, you can choose, like C and M, first or second, that doesn't matter. So I write here 1 minus 8 whole square plus, that is, you see C's coordinate 8 2 and M coordinate I get 1 3. So I write 1 minus 8 square plus 3 minus 2 square is equal to square root 8 minus 1 minus 7 square plus 1 square. Next, now squaring, I get 49 plus 1, that will be square root 50. And if you want to take it's 50, so 25 2s are, so it will be 5 root 2. So this is the first length we found, that is CM of our first answer, which is on the side AB. Now let us continue for the second, that will be of on the side AC. For side AC there is BL. BL, you can see in the figure, this is BL. BL is the median on the side AC. So we have to take point B and L coordinates to get our length. For that, again we'll use distance formula. So now that is BL. I do not write formula again. Now directly applying formula. So B coordinates 4 4 and L coordinates 3 2 I get. So 4 minus 3 square plus 4 minus 2 square is equal to 4 minus 3 1 plus 4 minus 2 2 square. So here I get 1 plus 4, that is square root 5. So that is the second length we found here of BL. Now the third length will be of on the side BC. So side BC, the length here we find using our formula only, distance formula. So you see on side BC there is AN on side BC. So we take A and N coordinates. So what N coordinates? We got 6 and 3. These are the coordinates of N, and A is minus 2 2. So I write AN is equal to square root 6 minus 2 means plus 2 plus 3 minus 2 whole square is equal to 6 plus 2 8 square plus 1 square. So it will be 64 plus 1 69. So that is answer is given 65. So how it possible? 64 plus 1 65 only, by mistake I wrote 69. So this is our answer number 3, 65 in square root. So now we got all the three lengths. You can see students, AN, then CM and then BL. So like you can find first midpoints and then you have to find the distances using the lengths using distance formula.
Question number 12, exercise 11A. Calculate the coordinates of the point P which divides the line joining A minus 1 3 and B 5 9 in the ratio 1:2. So here we have to find point P, which is the dividing point of line segment AB in this ratio. So we'll use our section formula. So let us take, this is x1, x2, y1, x2, y2. And let P be the point. So let Pxy be the division point here. Division point. So this is already explained to you students previously, but again I am explaining. This is very important how to use section formula. So now xy p point we want, so xy coordinates we want to find out. For that our section formula is mx2 plus nx1 upon m plus n and my2 plus ny1 upon m plus n. You can see formula. It is very simple. Here x2, here also y2, x1, y1, and with m and n and m plus n in the denominator. So it is very simple to remember also. Now I have already written m ratio n is 1:2. So m is 1, x2 value is 5 plus n is 2 and x1 value is -1. In division 1 plus 2, m 1, y2 9 plus n is 2, y1 3 divided by 1 plus 2. So now we calculate this. 5 ones are 5 minus 2 divided by 2 plus 1 3. 9 plus 3 2s are 6 by 3. So now 5 minus 2 is 3 and 3 divided by 3. 9 plus 6 15. So we write here 3 by 3, 15 by 3. So 3 get cut, 3 5s are. It means here I get 1 5, which is the point P, which is the division point of line segment AB. So our answer is 1 5, the coordinates of point P. So here this is our question number 12.
Question number 14, A part. Question number 14 is, A is the point on the y-axis whose ordinate is 5. Students, ordinate means y coordinate and point A is lying on y-axis. So I wrote x5. But you think, if this is the y-axis and if the point A is lying here, means the coordinate will be, x coordinate will be 0 and ordinate means y coordinate is already given 5. So the coordinates will be 0 5 of A coordinate. So remember, some students make mistake here. They do not understand that it lies on y-axis means it will be 0 5 coordinate. And here they ask to get length of AB. So again, length of AB means we will use our distance formula. So AB, for that x2 minus x1 whole square plus y2 minus y1 whole square. This is the formula. Now x1 y1 values here, x1 y1 and x2 y2. So these are the coordinates we are going to use to get our length of AB. So now x2 value is -3, x1 is 0 whole square, y2 value 1 minus y1 is 5 whole square is equal to -3 square is 9, 1 minus 4, 5 is -4, -4 square is 16. So now 9 plus 16, 25. And its square root will be 5 units. So our answer of question number 14, A part, is 5 units, because here we are not given any centimeters or anything. You can write AB is 5 only. Now students, question number B. In question number B, we have to find the midpoint of the line joining A2 and 3 6 is 2B. Okay, so midpoint is already given to us. So I am writing here. You can see now question number B, in which the line is joining as A2 and 3 6. This is the points of the end points of the line, and this is 2B, a midpoint. Midpoint is given as 2B. Okay, Then find the numerical values of A and B. We want to find numericals value. So here we apply our midpoint formula. So midpoint is equal to x1 plus x2 by 2 and y1 plus y2 by 2. Now midpoint is already here 2b. So I substitute it here and you see this is our x1 y1 and x2 y2. So now we apply it here in our formula. X1 is A, x2 is 3 divided by 2. Similarly, y1 is 2 and y2 is 6 divided by 2. Okay, so now you can see we can compare the x coordinates with x. It means A plus 3 by 2 is equal to 2. Now A plus 3, 2 2s are 4. So value of A I found 4 minus 3, 1. Similarly, I take B coordinates 6 plus 2, 8 by 2, that will be 4. So by comparing Y coordinate, I get value of B 4. So what they asked to get? Value of A and B, and values are found as 1 and 4. So we have completed our question number 14, A and B, both the parts. You can see both the parts of question number 14, A and B. Exercise 11A, question number 15. In question number 15, the line joining A 2, 3 and B 6 minus 5 meets the x-axis at P. So write down the y coordinates of P and hence find the ratio AP ratio PV. So here you can see I have drawn x and y axis. So if this is line AB and if this is the point of intersection which lies on x-axis, so the coordinates of P will be x0. It means the y coordinate will be 0. So here our first question, that what is the y coordinate? So here I write that y coordinate will be 0. Also they asked to get AP ratio PV. So for that let ratio be K ratio 1. Now we already know that y coordinate is 0. So I write y formula, that is m y2 plus n y1 upon m plus n. Now substitute y value 0 is equal to m means k, y2 minus 5 plus n mean 1 and y1 is 3 upon k plus 1. Now this k plus 1 multiplying with 0 become 0. So here I write 0 is equal to minus 5k plus 3. Therefore 5k is equal to 3 and k is equal to 3 by 5. It means we get k ratio 3 ratio 5, or you can say AP ratio PB is equal to 3 ratio 5. So this is what our final answer here. Question number 15, y coordinate is 0 and AP ratio PB is 3 ratio 5. Question number 16, exercise 11A. Now in the figure, P23 is the midpoint of the line AB. Write down the coordinates of A and B also. So here midpoint is given and A and B coordinates not given. So you see A is lying on OX, means it is on X coordinate. So the coordinates of A will be X0 and coordinates of B, that is lying on OY, means Y coordinate will be 0Y. So we can find now X and Y value according to midpoint formula. So P is the midpoint here. So I can write x1 plus x2 by 2 and y1 plus y2 by 2. Here this is x1, y1, this is x2, y2. Now P already known, 2, 3 here coordinates we are given. Now we substitute the value here, x1 and x2 and y1 and y2. So x1 coordinate is x and x2 is 0 upon 2. y1 0 and y2 is y upon 2. So we can compare x coordinate with 2 and y coordinate with 3 here. So let us compare. First of all, x by 2 is equal to 2 and y by 2 is equal to 3. So I get x value 2 2s are 4 and y 3 2s are 6. So here we can write now coordinates of A and B accordingly. As we have chosen A coordinate x0, so that will be 4 0 and coordinate of B will be 0 6. So this way you can see that A40 and B06 are the coordinates of our A and B. Exercise 11A question number 18. In this question, first A part, the coordinates of A minus 3A and coordinates of B 1A plus 4 and the midpoint of AB is minus 1 1. So find the value of A. So according to midpoint formula of AB, you can see minus 3 and 1 x coordinate. Only we need value of A. So we'll use that y1 plus y2 by 2, that is our y coordinate 1. So using that formula, A, y1 and y2 is A plus 4 divided by 2. So here I get 2A plus 4 divided by 2 and here is 1. So by multiplying here in cross, 2 is equal to 2A plus 4. So 2A is equal to 2 minus 4. 2A is equal to minus 2. So we get A value minus 1. So what they asked to get here? Find the value of A, and we found value of A as minus 1. So students, using our midpoint formula here, I have used midpoint formula to get our value of A. The first part is solved. Now listen the second part I am reading. Calculate the ratio in which the line segment joining 3 4 and minus 2 1. So here the B part I am writing. The two coordinates we are given. They are 3 4 and the other is minus 2 1. So these are the two coordinates. The line is joining and it is divided by the y-axis. It means this way y-axis is dividing some line whose coordinates are 3 4 and minus 2 1. Minus 2 1. This way some line is there and it is divided here in the y-axis. So coordinates on the y-axis, the point is there, it will be 0 y. The x coordinate will be 0. So here we want to find the ratio. So let ratio be k ratio 1 and accordingly using section formula. But you see which known value is known of the division point. The x coordinate is known whose value is 0. So I'll use here x coordinate formula mx2 plus nx1 upon m plus n. So x coordinate is 0 here because it is divided by y-axis. Also here x1, y1, x2, y2, the coordinates are written. Now let us substitute here m value k. The ratio here m ratio n is k ratio 1. x2 is minus 2 plus n is 1, x1 is 3 divided by k plus 1. Now this k plus 1 multiplied by 0, so it becomes 0. And here I get minus 2k plus 3. So the value will be 2k is equal to 3 and k is equal to 3 by 2. So we found here ratio, that is 3 by 2, or you can say 3 ratio 2. This is our final answer of second part, that B part of our question number 18. So here we have solved both the parts of question number 18. The first part answer is A minus 1 and the second part is 3 ratio 2, the ratio asked. Question number 19, exercise 11A, first part A, in which it is written P divides the distance between A minus 2 1 and B 1 4 in the ratio 2 ratio 1. Calculate the coordinates of the point P. So here P is the division point whose coordinates will be x and y. So let Pxy be the division point here, and we want to calculate values of x and y here. Already we are given ratio. So now here I write x1 y1. Always this is the habit, students. that you have to write the coordinates as x1 y1 and x2 y2. Then and then only it will not be any mistakes in the substitution of values. So now xy, so here m x2, and every time I am writing formula here because that it will be very in your mind for a long time. It will be there in your mind that this is the formula, section formula. Now m is 2 given already, x2 is 1 and n is 1, x1 is -2, m plus n 2 plus 1, m again 2, y2 4, n 1, y1 1, 2 plus 1 is equal to 2 minus 2 by 3, 8 plus 1 divided by 3. So here 2 minus 2, it means it gets 0. 0 by 3, it will be 0 only. And 8 plus 1 divided by 3, it means 9 by 3. So 0 and 9 by 3, we solve 3. So the coordinates of point P will be 0, 3. So our answer number 19 is point P's coordinates are 0, 3. So this way you can use section formula to get your values. Now question number B. Question number B is prove that the points A minus 5, 4. A minus 5, 4. B minus 1, minus 2. And C 5, 2. These are the three vertices given to us. A, B, C are the vertices of an isosceles right angle triangle. We have to prove this and find the coordinates of D so that ABCD is a square here. So this is very important question. So you can see question B, A, B, C are the three coordinates. We have to prove that they are the coordinates of isosceles right angle triangle. So for that, students, we have to first calculate the distance AB, BC and AC. And we show first of all any of the two distances are equal so that it is isosceles triangle. Okay, so first of all using distance formula, I write here AB. AB is square root. Now I directly put minus 1 minus plus 5 whole square plus minus 2 minus 4 whole square. AB's coordinate I am using. Then 5 minus 1, 4 square and minus 6 square is equal to 4 is 16 and 36. So it will be 52. Square root 52. Then we find BC value. For that I'll use BC coordinates. So 5 minus 1 plus 1 square. 2 minus 2 plus 2 square is equal to 5 plus 1 square, 4 square, 36 plus 16, again it is square root 52. So we got already two sides equal. AB and BC distances are equal. So no need to write now AC here. So we found AB is equal to BC. It means it is isosceles triangle. Okay, then we have to also find out that it is a right angle triangle because it is written that we have to prove this is vertices of isosceles right angle triangle. For that we have to show here that by Pythagoras theorem AC square is equal to AB square plus BC square. For that I will find AC square value. So for that I will not put the square root sign because we are finding AC square. Okay, so for that AC's coordinates I will use here, and the coordinates are, you can see in the question, minus 5, 5. So 5 minus plus 5 whole square plus 2 minus 4 whole square. Okay, these are the coordinates. Now after that 5 plus 5, 25 square, and this is minus 2 square. So this is 625 plus 4. It means 629. This is AC square value, 629. We do not need to take its square root, but it is 5 plus 5, 10. Sorry, not 25. And this is 100. So now it is 104. Okay. Now we will show that this is right angle. For that, by Pythagoras theorem, using Pythagoras theorem, I write here AC square is equal to AB square plus BC square. If these two distances are equal, then we can say it is forming right angle. Okay, so AC square value is 104. What is AB square? AB we got root 52, so square of it will be 52. And BC we got root 52 and square of it 52. It means this value is also 104. So here we can say that the triangle ABC is an isosceles right angle triangle. Okay, so here the first part we have proved that triangle ABC is isosceles right angle triangle. Also we have to find coordinates of D, so that it is a square here, it is forming a square. So for that, students, what we have to show according to our square property, that midpoint of AC, the diagonal of square, is same as midpoint of BD, the diagonal. For that, I write here, see, I show you by figure that if this is a square ABCD, okay, we have already proved AB is equal to BC and all sides will be equal if it is a square. So what we will show that the two diagonals here, they are AC and BDs. They will meet at the midpoints. Okay, so both of them's diagonals or midpoint should be similar. So we will find now midpoint of AC. So for that I write midpoint of AC first. A and C's coordinate will use here. So coordinate of A and C, it will be 2, 2 and minus 5, 4 and 5, 2. So I write minus 5 plus 5 by 2 and 4 plus 2 by 2. This is 0 and this is 6 by 2, 0, 3. This is the midpoint of AC. Similarly, I write midpoint of BD. For that, I'll use the diagonals, or you can say the coordinates of B and D. Okay, so B is known, but D is not known to us. So for that, let's write here the coordinate of B should be XY here, and then we will find value of X and Y. So B value is minus 1, minus 2. So minus 1 plus X by 2 and minus 2 plus Y by 2. So now comparing with 0, 3, that is the midpoint AC and midpoint of BD. So let us write accordingly here that midpoint of AC is equal to midpoint of BD, always in a square. So now substituting values, this is 0, 3 is equal to minus 1 plus X by 2 minus 2 plus Y by 2. Now we'll compare X coordinate and Y coordinate. So X coordinate comparison with 0, Y coordinate comparison with 3. 2 zeros are 0. So this is X is equal to 1. And here 3 2s are 6. So Y is equal to minus 2 go that side. 6 plus 2, 8. So here we get coordinates of D will be 1, 8. So our final answer is 1, 8, which are the coordinates of D here. So we have solved our question number 19, both the parts A and B here.